All right, so this is for my Math 261 students. We're going to go over question number 15 today on logarithmic differentiation. So question 15, you will get a problem that's asking you to find the derivative of the function. And I'll make up a function that is similar to what you will see. Find the derivative of the function. And here is an example. Y equals natural log of, make this up, 5x to the 10th power minus x to the 25th power. So I made something up. So how do we take the derivative of this natural log function? Well, remember, well, you know what? This is an exam review, so I'll just do it. Yeah, I'll just do it. So we will write this as 1 over the log argument. What's the log argument? 5x to the 10th minus x to the 25. So I just did 1 over this log argument. Okay? Now, don't forget, gotta use that chain rule. We need to now multiply this by the derivative of the inside part, the derivative of this log argument. That is 50 x to the 9th power minus 25 x to the 24th power. Okay, so I took the derivative of that blue underlined part, and now we just have to simplify this answer. Okay, so let's see. Y prime equals, I'm going to move that blue chunk to top of the fraction. Okay, so this goes to the top of the fraction, and in the bottom of the fraction we have this term right there. Let's see if we can simplify any greatest common factor of x. Okay, so the numerator, I can factor out 25 x to the 9th power. Why? Because the first one has x to the 9th power, the second one has x to the 24th power, so we go with the least common multiple of x to the 9th power. Okay, did I say something wrong? Oh, all right. Now, what's left inside? 50 divided by 25 is 2, so I'll write 2 here. But x to the 9th power divided by x to the 9th power, no more, so I'm not going to write any x's. I'm going to do the minus sign. 25 divided by 25 is 1. And now x to the 24th divided by x to the 9th, I just have to do 24 minus 9, which is going to give me 15. So I will have 1x to the 15th power. Now I go to the bottom of the fraction. Let me see if I can factor anything out here. Oh, no, not a number. Okay, but I can factor out x to the 10th power because the exponents are 10 and 25, so the smaller number is 10. So the greatest common factor will be x to the 10th power. If I factor that out, I'm going to have 5 minus x to the, now 25 minus 10 is 15. Now once I have it factored out, let me see if I can cancel these out. So I have x to the 9th power on top and x to the 10th power in the denominator. See who has more x, top or bottom? The bottom has one more. So here's my final answer. I'm going to have 25 2 minus x to the 15th over x, because the denominator had one more x, right? So I have one x left over in the bottom. And then inside the parenthesis, I'll write 5 minus x to the 15th. I feel like this problem, I did more on simplifying than finding the derivative, because that was just the first line. But this one I thought was a log differentiation, but no, this is just differentiating a natural log function. We're continuing our final exam review. This is for question number 15. We are differentiating this natural log function. So y equals, and I made this up very similar to what you will have, but how do we differentiate a natural log function? You're going to start by writing 1 over. that log argument. My argument is this. I'm going to put that in the bottom of the fraction. 5x to the 10th minus x to the 25th power. Now don't stop there, because now you will have to multiply this by the derivative of that inside function, which is a log argument. So what is the derivative of 5x to the 10th? 50x to the 9th minus the derivative of x to the 25th power will be 25x to the 24th. All right, that's it. Now, that's how you differentiate, but let us try to simplify this a little bit, okay? Alrighty, I'm sorry. So I'm back. Let's finish this. So, I'll put that blue on top of the fraction, okay? So this will be the numerator that we should try to simplify. And there's the denominator. We may be able to cancel some things out on top and bottom. So, how can I factor out that numerator? I can see that I can factor out 25 because there's 50 and there's 25. The greatest common factor is 25. So I'll factor out 25. Okay. And let me look at the x's. Okay. This is x to the 6th power. This is x to the 24th power. So the greatest common factor will be x to the 9th power. So x to the 9th power. I'll draw a parenthesis and I'm going to put the quotient inside. 50 divided by 25 is 2. And x to the 9th divided by x to the 9th is just 1. So first term becomes 2 minus 25 divided by 25 is 1. But x to the 24th divided by x to the 9th, I have to subtract the exponent. 24 minus 9 is going to be 15. So this one will become x to the 15th power. Next, I go to the bottom of the fraction. I can factor out x to the 10th and have 5 minus x to the 15th. And I can tell that I will be able to factor or cancel out this and change this exponent to 9, right? Because if you look at these two, the top and the bottom, the denominator has one more x. So this is going to be my final answer. Look, my final answer is going to be 25, 2 minus x to the 15th over x times 5 minus x to the 15th. All right.